This is the current sensor. It's used in our physics book for doing circuit labs, and so it measures the amount of current flowing in a circuit. And the way it works is that it has a 0.1 ohm resistor in there, and as the current flows through there, we can actually measure the potential difference across there, and we can actually determine how much current's flowing through the circuit there. Now, you want to be careful with this because you are having the current flow through there. It is possible for you to damage the device. It's designed to go up to no higher than 0.6 amps. And if you go higher than that, you can damage it. The voltage range is plus or minus 10 volts. And so it's intended for battery and bulb kind of experiments. You're not going to hook it into a powerful AC circuit or maybe use it with a very large power supply. You want it really intended for battery and bulbs. So what I've done here is I have the Vernier circuit board, and I'm going to use this along with the current sensor to make some measurements this morning. I'm going to plug in my current sensor, and when we do this, it shows our current value there. It's reading close to 0. It's got a little fluctuation there, but it's actually very close to 0 here. I don't have it actually in the circuit. And what I've done for my circuit board here is I have these 3 light bulbs I have wired in parallel to each other. And what I will do is measure the current flow through this circuit as I remove some of the circuit elements, as in unscrew the bulbs from here, and we watch what happens to the current value. So that would be something you might do in an experiment. And so the first thing I need to do is to wire this up. And I've got it so that this side is the is on the positive side of the circuit there. So I'm going to trace my path through here. So I want it to go, if I want it to read a positive value for current, you can read positive or negative. Remember that we say a positive current is one where we're going from positive to negative on the battery. It's just by convention. And if you do it wire it backwards, you just get a negative value. So it doesn't really matter. But in this case, we'd like it to be positive there. So I want it to come through here. And so if I hook it up this way, it should give us the value we need here. So I should have everything hooked up and ready to collect data. And if we look on our LabQuest 2 here, if you look up in the upper right corner, we'll see our default collection parameters. It's a time-based 10 samples per second for 18 seconds. So it's designed to be able to do a lab like this without really having to set up any of the collection parameters. I can just collect data and be able to do that. So what I would like to do is I'm going to begin collection, and as soon as I begin collection, I'll let it collect for just a few seconds. I'm going to throw the switch, and when I do that, the light bulbs will light, and then I will slowly remove them in turn from the circuit, and we watch what happens to the current flow in the circuit. So let me start collect. And so now I'm going to turn the lights on, and then slowly I will remove one, remove the other, and then lastly remove the last one. Taking a look at our data, we see that the current first started off down here at 0. I turned it on. It went up very high. These are light bulbs, and they're essentially wires, and the resistance changes as they heat up, so they kind of level out here. But this would be where all 3 bulbs were on, and then I removed one of the bulbs, and so we had 2, and then we get down to the last bulb, and then I removed all of them. I might be interested in what is the amount of current flowing in the circuit, and there are ways to be able to do that. One way would be to use the examine function. I could just pick some point along that part of the graph and do that, and then just read the value from my meter over here. So I could just go, and it seemed to be roughly constant there, so maybe I could just do it that way and get a value. It might be better to actually do an average, and so if I highlight that section of the graph where it is has all 3 in there, I might go to Analyze and do statistics, and we could read the mean value for the current there. So I get 0.23 amps for that section. Then maybe I do another section, turn that one off, so I could come over here, maybe analyze this section, and it drops to 0.17 amps. And then lastly, if I wanted to do the last one there, could come and highlight that region, analyze statistics, and now it's down to 0.11. So it is indeed dropped down. And then I guess lastly here we could just examine that one, and we see that it's back down close to 0. Current sensor, great for using it with battery and bulb experiments. We mentioned one of the limitations about being the amount of current, being that 0.6 amps. We do have a high current sensor that allows you to measure up to 10 amps. So if you're doing something that involves higher currents, and it also operates at a higher voltage range, perhaps using a photovoltaic panel, you could use that. But for simple battery and bulbs experiments, the standard current sensor is a great device to have.